Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating systems. So this subject is for the students studying in their 5th semester of their BSc degree program. This paper operating system belongs to paper number 8 of their 5th semester. So in today's lecture we are going to see few topics from unit 5. In unit 5 there are several topics, out of which we are going to concentrate on topics such as performance, secondary storage structures, the protection, goals, domain, access matrix, the security problem, authentication, threats, threat monitoring and encryption. So we have already seen a topic on IO system in one of our earlier lectures. So this lecture will be a continuation of our previous lecture. So in this lecture, I will give you a quick recap of whatever we have seen in our earlier lecture. In our earlier lecture, we saw what an IO system is, what is an IO device, how an IO device communicates to the operating system, and I showed you kernel architecture, kernel subsystem architecture. Then I also explained about the performance issues in using a kernel subsystem, kernel IO architecture. Now in today's lecture we will be seeing the contents as the principles of protection, domain structure and its implementation, access matrix, the security problem, security violation methods, security attacks and how to monitor the security attacks, then about the program threats, and then about the encryption as well, the types of encryption. Now what is protection? What are the principles of protection? How do you protect your system? If you want to safeguard your system, safeguard the IO devices, what is an IO? Because in this lecture, since if you are new with IO is input output system. So if you want to safeguard your devices, it has to be protected. Now what are the guiding principles required for protection? It is, we require certain privileges for access. If I want to access the keyboard, this keyboard should be given due privilege and this mouse should be given privilege and the printer should be given certain privilege, or even we can say it as a priority. Now here this guiding principle is principle of least privilege. So the programs, users and system should be given just enough privilege to perform their task. It limits damage if entity has a bug and gets abused. You would have seen this. Supposing if you have a operating system, if you have installed an operating system and if it is pretty new, let us consider you have installed Windows XP operating system and if it is pretty new, then the execution time taken, if you want to access a particular file, the execution time will be much more faster. Supposing if the other example, supposing we have installed an operating system sometime earlier, somewhere around that installation has taken place some 2 years before, and now you cannot get the same speed as you could have in installing a new operating system. This is why this happens. It is because in your older operating system there is a possibility that an virus would have entered in, and there is a possibility that there may be a bug in the code. There is a possibility that you would have deleted certain DLL file. What is a DLL file? It is a library file that has been inbuilt for an operating system to perform. So if you have done any of these tasks, then definitely the performance of the operating system will be pretty slow. So even you are not supposed to delete all these things and you are supposed to check for the virus attacks or for the worms attack or for the Trojan horse attack. We will see what a virus is, what a worm, what a Trojan horse. What is a virus? Virus is vital information resource under siege. So it is a software which attacks the system and it slows down the system. A worm is, it is present internally in the operating system after installation. What happens is that it will be residing silently and supposing if you try to execute it, then it starts its execution from the background. And this Trojan horse, it starts its execution when your system has been connected to a network. So in the virus case, in the case of virus, it gets affected, your individual standalone system will get affected. In the case of Trojan horse, your system may be perfect, but your neighbor system would have been affected with virus. So since it has been connected through LAN, network connected, the virus may get affected from that system, it will come to your system. So there is a possibility, and because of this your system may get slowed down. So this has to be protected. The other thing is, it should be dynamic or changed by process as needed, that is, it should have a domain switching, or privilege has to be escalated, that is, you should be given more privilege, this system has to be given more privilege when compared to a neighbor system. If you think your system should be more secure, and if you think that you have more valuable data when compared to other system, your privilege level has to be escalated in terms of working with the networked environment. So the other aspects of the principles of protection are, it must consider grain aspect, that is, rough grained privilege management should be easier, simpler, but least privilege is to be done in terms of large chunks. For example, in the case of Unix operating system, in the case of handling a traditional Unix processes, either have the ability of the associated user or of the root. I said in one of my earlier lectures, when you want to access a file, that particular file has to be mounted. First of all, it should be mounted in order to access that particular file. If it has not been mounted, you cannot access the file. Similarly, after closing the file, that particular file has to be unmounted. That is there in Unix, and for mounting and unmounting, it goes to the root and then it gets mounted out. So that is what has been said over here, as it has the ability of the associated user or of the root. Fine grained management or more complex, more overhead, but more protective, and the domain can be a user, process, or a procedure. So these are the principles of protection. Now let us see, what is a domain? What is a domain? What is a domain structure? See, you would have heard in your when you could meet some of your friends who is working in the software industry, people will be asking, what is the domain in which you are working? What is the platform in which you are working? Do you mean to say that both domain and platform are one and the same? No. Domain is said to be the banking domain, finance domain, insurance domain, retail domain. Platform is said to be the language that he is working in, something like .NET, something like Java, something like C, C++, embedded, VLSI, so on, VHDL, so on. So platform is different and domain is different. So now we are going to see only about a domain structure. So how the domain structure works with respect to an IO system. Here this IO system domain structure should have an access right. Access right is the right that is required for accessing a particular device. Say for example, you may be having a set of computers which is being networked in a group, but you will not be given the access to take printout. Only one system which will be kept in common, which has an access to print. So that access right has been denied for your system, whereas the access right has been given to the other system which is able to communicate with the printer device. So that is a domain structure. And the other thing is, domain said to have a set of access rights. Now in the case of domain implementation, a domain is equal to the user ID. The domain switch accomplished via file system. So in other words, say for example, in your system, when you are going to log in with your username, you may not be able to access an internet. Supposing if the administrator logs in the same system, he will be in a position to access the internet. That is because of the access right. And then in the case of domain implementation, the domain switch accomplished via passwords. So these are the ways in which the domain gets implemented. First thing is it got accomplished via a file system. Then in the case of file system, if you are able to access and if the other is not able to access, then that is because of file system. Second is it is accomplished via passwords, that is you give password to it for accessing a particular privilege, for using a particular privilege you assign certain passwords to it, and SU, when you type SU to commands, it temporarily switches to another user's domain when other domain's passwords are provided in the case of Unix operating system. In the case of Windows operating system, you just like you give a password and you will be in a position to access the IO devices. Then the other domain implementation is domain switching via commands. So again, in terms of Unix operating system, sudo command prefix is used to execute a specified command in another domain if original domain has a privilege or password given. So these are the ways of accessing a domain, and this is how a domain gets implemented. Now let us see the access matrix. What is an access matrix? An access matrix is used to view protection as a matrix, and these rows in the access matrix represent the domains, rows represent the domains and the columns represent the objects. So access of ij is the set of operations that a process executing in domain I can invoke an object j. Let us see with a tabular column example. So this is how an access matrix looks like. So this row represents the domain, column represents the object. Here we have D1, D2, D3, D4. So in this row we have read operation and read operation, whereas this domain 2 has the print mode, and that is the reason it could print and it can have an access to the printer device. Domain 3 has a read operation and an execute or a write operation. Domain 4 has a read and write operation, and in domain 4 in F3 it again has a read and write operation. So this is how an access matrix table has been framed into, and this says how to access a particular file, how to access, how to assign privileges, or how privileges are being assigned to a particular file system for a particular user with respect to the IO devices. Then the next topic is about the security problem. What sort of security issues that we may get. Now let us see the difference between a threat and an attack. What is a threat? For security we require both threat and attack. So what is a threat? A threat is a potential security violation, whereas an attack is an attempt to breach the security, is to violate the security. Now a system is secure if the resources used and accessed as intended under all circumstances, that is, which is unachievable, and intruders, or otherwise called as a crackers, attempt to breach the security. So an attack can be accidental or malicious. Easier to protect against accidental than malicious misuse. So this is a major point wherein we are supposed to know the difference between a threat and an attack. A threat is a security violation, whereas an attack is a breach in security. Now let us see the security violation methods. There are several security violation methods available. We will see one by one. First one is masquerading. What is masquerading? Masquerading is breaching the authentication. What is breaching? Violating the authentication. So pretending to be an authorized user and to escalate privileges. Say for example, you are a user. You do not have access to a computer, to a printer resource. But if you pretend as if you are an administrator, and if you try to gain certain access rights as that of an administrator, then you are a masquerader. You are called as a masquerader, wherein you are violating your access rights. This computer does not have a printer access, and supposing if you type in your administrator key in and administrator password, and if you try to enter in through this computer, this can be tracked through the IP address of this computer that is available inside the computer. So, which means that you are violating, and you pretend as if you are said to be the original user and you pretend to execute the task. That is called masquerading. The second violation method is replay attack, as is or with message modification. So, you get a message and you try to see the communication, how it gets communicated from one system to the other, one device to the other, and you try to check the validity, check the path, and you try to replay it. It is called as a replay attack. So, that is also a violation of security models. Then the third point is man in the middle attack. What do you mean by a man in the middle attack? Here the intruder sits in the data flow and masquerading as sender to receiver and vice versa. In the middle, this intruder will be sitting. As sender, there will be a communication which will take place from the sender and to the receiver end, and there will be a communication from the receiver to the sender. In between, this intruder will be sitting. What he will do is, he will track the path of sender and receiver, and he will be monitoring what these guys are communicating, what the sender and receiver is communicating. So, what happens here is, after a while, this intruder, the sender communication will be sent to the intruder, and this intruder in turn responds to the receiver, and the receiver in turn responds to the intruder in turn responds to the sender. So, but that has not been known to both to the sender and receiver. That is called a man in the middle attack. Then the last security violation method is session hijacking. Intercept an already established session to bypass its authentication is called session hijacking. Now, let us see a diagrammatic view of how the intruder works, how the intruder sits and hijacks all the messages. So, here in this, the sender sends a communication and the receiver receives it. The receiver sends a communication and the sender receives it. The attacker is viewing. Now, in the case of masquerading, the sender sends communication, which this attacker will be in a position only to view, but this communication after viewing, if he is not sending also, if the attacker has received the from the receiver all the details of this receiver system, if it has been received by this attacker, then the attacker will communicate to the receiver, and the receiver in turn will communicate to the attacker, aiming that he is communicating to the sender, but actually speaking, this receiver is not communicating to the sender, and only this attacker is communicating. That is called masquerading. Man in the middle attack denotes the attacker will be communicating to both sender and receiver. That is called man in the middle attack. So, these are the standard security attacks that are possible. Now, let us see the program threats. What are the different program threats that may encounter? Now, I was speaking about a Trojan horse. A Trojan horse is also a virus which takes place through a network. Now, here in this Trojan horse, a Trojan horse is a code segment that misuses its environment. It exploits mechanism for allowing programs written by users to be executed by other users. It is a spyware or a pop-up browser window which covered the channels. Up to 80% of spam delivered by spyware or infected systems. Supposing we are going to use mailbox, say for example yahoo.com, or if you have a mail ID in Gmail, you will be having a separate spam folder wherein you will get all sort of junk messages. When you try to click in, your system may get affected by virus. It may or it may not get affected. Supposing if it is going to get affected by virus. So, 80% of the mails that has been put on the junk folder are said to be in the spam folder, or said to have a virus which has been passed through a Trojan horse. Now, we will see the other programming threats. The second program threat is Trapdoor. It specifies a user identifier or password that circumvents normal security procedures. It could be included in a compiler. The third program threat is the logic bomb. The program that initiates a security incident under certain circumstances is called the logic bomb. Then the next thing is about, this is what a program threat, and we have one other program threat which is called as the stack and buffer overflow. Exploits a bug in a program. Failure to check bounds on inputs or arguments. Arguments are the parameters. Write passed arguments on the stack into the return address on stack. Unauthorized user or privilege escalation leads to stack or buffer overflow. Then we will see the layout of a typical stack frame. So here it is. Here we have a return address, saved frame pointer, automatic variable and parameters. So this is a frame pointer. So this layout denotes the program threat. So this is how it works, and it grows from the bottom and it reaches to the top. So based on the explanation given for stack and buffer flow, this diagram is shown. Now let us see what an encryption is. What is an encryption? What is encryption and what is decryption? So supposing if we are going to make a communication between the user, that is a sender and a receiver. So when you are going to make communication, you infer that you have checked that whether someone is trying to hack all your information. So in that case, you are communicating, the sender is communicating, the receiver is receiving it. The receiver is communicating, the sender is receiving it. That is client A, let us consider A and B. When A is communicating to B, B receives it. When B is communicating to A should receive it without any issues. That is said to be a wired communication. If it is of an unwired, or even in the case of wired, let me give you a practical example wherein you are speaking with your friend on a telephone. Telephone is a wired communication. So here when you speak to your friend on a telephone, at the top of your house the telephone wire will be going to a nearby cable unit. So supposing if someone has made a small cut in the telephone wire and someone is putting a tap on the telephone wire, and if they are going to use their own telephone and if they are going to listen, then they are said to be the attacker, they are said to be the intruder, wherein they are listening the communication from A to B and in turn from B to A. So this is a severe program threat. So now what you do is, you have inferred that there is a communication, someone is listening to your information, someone is making a crosstalk of all the informations. So now what we do is, we try to encrypt the message. Encrypt is, you have a communication, but the thing is, you might, when you are sending it, you send it in a different format. When you say hello or when you say hi, HAI, you increment that HAI with two different alphabets. With two different alphabets is, I suppose everyone knows the alphabets from A to Z. H plus 2 becomes HIJ. So J becomes the first character. After A, B, C becomes the second character. Then I, after I, K becomes the third character. So H is nothing but K. So H, I, J and J, C, K becomes your hi. You try to say it as hi, but instead of saying it as hi, you are saying it as JCK. So when the intruder listens to your message, he cannot understand what, he might be wondering what JCK is. It is because you have encrypted the text. You wanted to say hi and that guy in turn says JCK, and this intruder will not be in a position to understand what you people are saying. That is encrypting. You are manipulating the original message and you are giving it a value, and then you are trying to send it to the receiver, and the receiver in turn, receiver has to decrypt whatever you have said. When you say JCK, he has to minus 2, he has to do minus 2 in the alphabets, and then he has to get the value as HAI. That is called, when the receiver does like this, he is doing a decryption, that is called decryption, and you are encrypting. And he in turn, when he says JCK, you are supposed to minus the values and you are supposed to get it as HAI. That is said to be decryption in your part. So this is what encryption is. Encryption is changing the original text into a different format. That format you call it as a ciphertext. When you change the original message to a different format, we call it as a ciphertext. So here is it. So this guy is writing a message and it is a plain text, and this fellow, this sender, he is encrypting the message using some algorithm, and then he is sending it, and he is intimating the key to the receiver so that the receiver will decrypt using an algorithm and he reads the original message. That is called encryption. Then the encryption algorithm consists of k keys, and it has keys and messages, and when you encrypt a message, you call it as a ciphertext. Now let us see the two types of encryption. One is symmetric encryption, other one is asymmetric encryption. Symmetric encryption is same key is used to encrypt and decrypt, and here we use an algorithm called as DES algorithm. DES algorithm is the most commonly used encryption blocks encryption algorithm, symmetric block encryption algorithm. We have DES algorithm, ADES algorithm, and DDES algorithm, double data encryption algorithm. DES denotes data encryption standard, and ADES denotes advanced data encryption standard. DDES denotes double data encryption standard. We have triple data encryption standard even. So all these DES algorithm come under symmetric encryption algorithm. Now we will see one other encryption type as an asymmetric encryption. That is, here in asymmetric encryption we use a public key encryption, which is based on each user having two keys. One is a public key, other is a private key. This public key is a published key that is used to encrypt the data, whereas a private key is a key that is known only to individual user used to decrypt the data. It is not known to the other user. That is called as a private key. So this is how we use in an asymmetric encryption. So now let us summarize whatever we have seen in today's lecture. We have seen the principles of protection. We have learnt about the domain structure and its implementation. We have learnt about the access matrix. We have seen the common security problem. We have discussed about the security violation methods. We have as well seen the various security attacks and the ways to monitor it. We have discussed about the various program threats. We have learnt about the encryption and the different types of encryption, that is symmetric encryption and asymmetric encryption. Now let us see the possible questions that could arise from today's lecture. So question number 1, what is a threat? What is an attack? Or even we can say it as, what is the difference between threat and an attack? Mention the various security violation methods. List the various program threats. What is encryption? So with this we come to end of this IO system topic. Thank you.